This file has an audio description of how to solve the 8th problem in the Diffusion and Osmosis problem set. Problems 6 through 8 illustrate basic concepts and skills for using the Nernst equation. This is the simplified version of the equation where Z equals 1, which can be used for monovalent cations such as potassium ions. The cell has a higher concentration of potassium inside than outside. The cell has potassium channels, and the membrane is permeable to potassium. What can we say about the relative amounts of potassium that will remain inside the cell and be outside the cell after potassium has reached an equilibrium, after the potassium diffusion potential has been reached? Remember that a diffusion potential is an equilibrium potential. There will only be net movement of potassium out of the cell until the time at which a negative charge builds up inside the cell. The strength of that negative charge, the inside negative membrane potential, will exactly balance the tendency of potassium to leave the cell due to the higher concentration of potassium inside the cell than outside the cell. An important concept is that it takes only a small amount of an ion, such as potassium, to cross the cell membrane before a large electrical potential is built up. The electric force is very strong, and it only takes a small amount of potassium leaving the cell to create an inside negative membrane potential that's powerful enough to counter even a large concentration gradient, such as that shown here for potassium. When the cell reaches equilibrium, the concentration of potassium outside will not have increased significantly, and the concentration of potassium inside will not have decreased significantly, even though some potassium will have left the cell. The answer to problem 8 is choice C. Even after potassium has reached the equilibrium potential, the concentration of potassium inside will remain greater than the concentration of potassium outside. Very little potassium has to leave the cell in order to produce an inside negative membrane potential that will exactly balance the tendency of potassium to leave the cell due to the higher concentration of potassium inside the cell.